So welcome to Mentor Tata classes. Now I am going to discuss some numerical problem from um, geophysics. Okay, for your upcoming CSIR NET art science paper. And today I have picked 5 questions from your previous year's question, and I am going to discuss the solution of these numericals. Okay, so now my question 1 is the number of maximum possible 6 layer Schlumberger sounding curve will be dash. Okay, so actually these Schlumberger sounding curves are same as vertical electrical sounding. Okay, so what is vertical electrical sounding? What is VES? Vertical electric sounding is method mainly used in groundwater investigation. And the purpose is to know the electric resistivity along depth. To know the electric resistivity along depth. Okay, so here we use the resistivity. Okay, so suppose we are considering 3 layer, 4 layer, 5 layer. Okay, so in case of 2 layer, number of possible curve is 2 to the power 2 minus 1. Okay, in case of 3 layer, 2 to the power 3 minus 1. In case of 4 layer, number of possible curve is 2 to the power 4 minus 1. That is, in case of 2 layer, number of possible curve is 2 to the power 1 is 2, 2 to the power 2 is 4 for 3 layer, and for 4 layer problem, number of possible curve is 2 to the power 3 equals to 8, and for 5 layer, number of possible VS curve or Schlumberger sounding curve is 2 to the power 5 minus 1 equals to 2 to the power 4, that is 16. And for 6 layers, number of possible Schlumberger sounding curve or vertical electric sounding curve is 2 to the power 6 minus 1, that is 2 to the power 5 equals to 32. So for n number layers, number of maximum possible VES curve is 2 to the power n minus 1. Okay, so always use this formula. You will easily understand, or you can easily determine the maximum possible curve for n numbers of layers. So now let's go to other problems. So this is next problem, and this is from seismology. So a P wave is incident at an angle of 30 degree upon a horizontal interface separating two media which are both Poisson's solid. If the p wave velocity of the first layer is 3 km per second and the critical angle is 60 degree, then the angle of refraction of the shear wave is dash. So which of the following option is correct, you have to choose. Okay, so of course this is a numerical and you have to calculate first and then you have to match with your options. So let's do it. So let's start. Suppose just draw a image. So this is interface between two medium and this is normal to the interface. A p wave is incidenting at an angle of 30 degree and this p wave creates two refracted component, one is p and another is s. Suppose this is p wave and this is s wave. Okay, so you have to determine this angle. Suppose this angle is theta r. Okay, this is the angle of refraction of the s wave. So in this question it has been given that the materials are Poisson's solid. So for Poisson's solid, Lamb's constant. So in the question it has been given that both the mediums are Poisson's solid. So in case of Poisson's solid or for Poisson's solid, Lamb constant and shear or rigidity modulus are equal. Okay, so bulk modulus will be 2 by 3 mu plus Lamb's constant. So this is a formula of bulk constant. So now as we know that Lamb's constant and shear modulus are both equal, so 2 by 3 of mu plus mu equals to 5 by 3 of mu. Now velocity equation of p wave is Vp equals to 4 by 3 mu plus k by rho. Rho means density of the medium. Okay, so it will come as, just put k equals to 5 by 3 of mu. If you put this value, so it will become 4 by 3 of mu plus 5 by 3 of mu by rho. Okay, so it will come as root over 3 of root mu by rho, and we all know that root over mu by rho is the formula of S wave velocity. So velocity of S wave will be root 3, velocity of P wave will be root 3 times of velocity of S wave. Okay. Now for medium 1, it has been given that the velocity of P wave is equals to 3 kilometer per second in the numerical. Okay, so velocity of S wave will be root 3 kilometer per second. Okay, so how it has been calculated? So let's see. So Vp1 is equals to root 3 times of V of S, as we know, or as it is given, Vp1 is equals to 3, then 3 equals to root 3 of Vs, therefore Vs equals to root 3 kilometer per second. Okay, now just consider the second part of the numerical. Now the critical angle is 60 degree. Okay, so critical angle is 60 degree. So let's draw another diagram. It is something like that. Critical angle of P wave is something like this. Okay, where critical angle theta c is equals to 60 degree. So sin theta c equals to Vp1 by Vp2 according to Snell's law. Okay, so you have to determine Vp2 first, that is velocity of P wave in medium 2. Okay, so this is your medium 1 and this is your medium 2. So now Vp2, velocity of P wave in medium 2, is equals to Vp1 by sine of 60 degree. That is equals to, so Vp1, as we know, it has been given that this is 3 kilometer per second, and divided by sine 60. Sine 60 means root 3 by 2. So it comes as 3 into 2 by root over of 3. That is 2 root 3 kilometer per second. So for medium 2, velocity of P wave is 2 root 3 kilometer per second. So velocity of S wave for medium 2, it becomes as we know this relation, so velocity of S wave will come 2 kilometer per second. Okay, and we have considered that theta r is the angle of refraction of S wave, and now we have to determine this theta r. Okay, so theta r we have to determine. So theta r is the angle of refraction of S wave. So now just consider this situation, this diagram. Okay, so incidental angle is 30 degree and angle of refraction is theta r. Okay, theta r of S wave. Okay, we are not considering the P wave, we are considering the S wave of the medium 2. Okay, so now again we will consider the Snell's law, that is sine of theta I by sine of theta r equals to Vp1 by Vs2. We will not write Vp2, we will write Vs2 for this situation, because we have to determine the theta r angle, and theta r angle is the refraction, is the angle of refraction of S wave in this numericals. Okay, so theta I, what is theta I? Theta I is equals to this is this 30 degree equals to theta I, right? This theta I equals to 30 degree. So this is 30 degree. So sine of 30 degree by sine of theta r equals to Vp1. What is the value of Vp1 and Vp2? So Vp1, that is velocity of P wave in medium 1, is 3 by velocity of S wave in medium 2 is 2, right? So this is your Vs2 and this is your Vp1. Okay, so now sine of theta r equals to 2 by 3 of sine 30 degree. So now 2 by 3 sine 30 means half. So theta r equals to sine inverse of 1/3. So here is another question from your PYQs. Okay, so let's read this question together. The question is, calculate the ratio of transverse strain to longitudinal strain in a granite sample which has a P wave velocity of 6 km per second, and the value of the Lamb's parameter lambda is twice that of the shear modulus of the rock sample. Okay, so what are the given datas? Given datas are velocity of P wave is equals to 6 km per second, and Lamb parameter is equals to twice of the shear modulus, equals to 2 of mu. Okay, so now we know that there is a relation between transverse strain and longitudinal strain with the Poisson's ratio, right? So what is the relation? The relation is something like that: transverse strain by longitudinal strain is equals to Poisson's ratio, which is lambda. Okay, and again we know another equation, lambda is equals to, so you have to calculate the ratio between transverse strain to longitudinal strain. That means you have to calculate the Poisson's ratio. Okay, so Poisson's ratio is equals to Lamb's parameter by 2 into Lamb's parameter plus shear modulus. Shear modulus means mu. So it has been given that Lamb's parameter is equals to 2 of mu. So put 2 of mu instead of lambda. So it becomes one third, that means 0.33. So your option number 3 is correct. Here is another question regarding the VS curves, and this has also been taken from your previous year's questions. So which of the following VS curve is not possible over a sequence of homogeneous layer? So there are 4 options, and these 4 options are indicating a specific type of VS curve, and you have to choose which of the following curve is not possible. Okay. In case of 3 layer problem, suppose this is your 3 layers. Okay, so this is layer 1, this is layer 2, this is layer 3, and resistivity of L1 is rho 1, resistivity of layer 2 is rho 2, resistivity of L3 is rho 3. Okay, so now let's see for which conditions the relation between rho 1, rho 2, rho 3 may satisfy, may not satisfy. Okay, so here it has been given that the name of the curves are in 2 parts. One is suppose K, so other part is H. Okay, so it means this is 4 layer problem. Okay, so 4th layer, let's the resistivity of the 4th layer is rho 4. Okay, suppose it has been written that it is simply K or simply H or simply A, so that means this is a 3 layer problem, but it has been written that KH, AK, HA, KA, so it means it is 4 layer problem. Okay, so let's consider one by one. So for first condition, KH curve. So KH curve, there is first part is K and second part is H. Okay, so this K part consider only the first 3 layer L1, L2, L3, and H part considers L2, L3 and L4. So for K, rho 1 is less than rho 2 and rho 2 greater than rho 3, and for H, rho 2 is greater than rho 3 and less than rho 4. So in this case, just look at this. The last 2 part of the K and first 2 part of H are same in condition. So KH curve is possible. Okay, as these two are same, so this curve is possible. Okay, so now AH curve. So there is again 2 part, one is A and another is K. AK, sorry, AK, right, AK. So for A, rho 1 is less than rho 2 is less than rho 3, and for K, rho 2 is less than rho 3 is greater than rho 4. So for this situation, these two are similar, so AK is possible. Now consider the option number 3. So this is HA. So here is again 2 part, H and A. For H, which is satisfying the first 3 layer or which is considering the first 3 layer. So for H, rho 1 is greater than rho 2 less than rho 3, and for A, rho 2 is less than rho 3 less than rho 4. So here the last two resistivity of H and the first two resistivity of A are similar, hence HA curve is also possible. Okay, and now come to the last option, which is KA. So again here is two part, one is K and another is A. So for K the situation will be rho 1 less than rho 2, rho 2 greater than rho 3. Okay, and for A type of graph, rho 2 is less than rho 3 is less than rho 4. So now for K, the relation between rho 2 and rho 3, and for A, the relation between rho 2 and rho 3 are not same. These two are not same. To satisfy K graph, you have to see that rho 2 must be greater than rho 3, and to consider A graph, rho 2 must be less than 3. So these things are completely opposite to each other. So this KA type of curve will not possible. So this is another question from your previous year's question of Earth Science Geophysics part. So let's read the question. Compared to the gravity field measured at the surface, the one measured at the bottom of a 200-meter deep borehole through a medium of density D such that pi dg equals to 0.06 milligal per meter will be, which of the following options will be correct? You have to pick that. Okay, so in this question it has been given that pi dg equals to 0.06 milligal per milligal per meter. So you don't know the density, okay, but you know the value of g. So the value of g is 6.67 into 10 to the power minus 11 meter cube kg inverse second to the power minus 2. If you want to determine the value of density in CGS unit, you have to put the value of g in CGS unit also. So 6.67 into 10 to the power minus 11 into, to convert meter into centimeter, you have to multiply this part, and to convert this kg into gram you have to multiply with 10 to the power minus 3. Okay, so it will come in centimeter cube gram inverse second to the power minus 2. Okay, so that will be the value of g. So now d will be equals to 0.06 milligal per meter by pi into g. So to convert this milligal per meter to milligal per centimeter, you have to multiply with 10 to the power minus 3 by pi into 6.67 into 10 to the power minus 11 into 10 to the power 6 into 10 to the power minus 3. Okay, gram per cc. So if you solve this, it will come as 2.86 gram per cc. Okay, So right now we know the density, and you have to determine the change in gravity for a depth of 200 meter. So the change of gravity caused by combined free air anomaly and Booger slab del G in millibar between two stations vertically separated by Z depth in meter is del G by del Z equals to 0.3086 minus 0.0838 of density D milligal per meter. Okay, so here del Z equals to 200 meter and D is equals to 2.86 gram per cc. So del G will be 0.3086 minus 0.0838 into 2.86 multiplied by 200 milligal, which is equals to 13.786 milligal, so which is nearly 14 milligal. Okay, so this is larger by 14 milligal. Okay, so option 3 is your correct answer.